Okay, so in this video, we are going to look at dilations. It's on page 23 and 25 in the packet. Okay. So first off, what are dilations? So dilations or size transformations result in similar figures. So dilations is when we are either enlarging or shrinking a figure or reducing a figure. And since they're similar and not congruent, they're not isometries. So dilation is the one transformation we do that is not an isometry. For each dilation, there are two important pieces that will be needed and given: a center and a scale factor to start. The image and the preimage will be collinear. Okay, so if you draw a line between the image point and the preimage, they'll be on the same line through that center point. And similar figures maintain angle measures and parallel lines, but all the distances or lengths will be proportional. So for similar figures, the sides are proportional, they are not congruent. In other words, if the scale factor is 3, then the lengths of the image after the dilation will have a length 3 times the original length in the preimage. Now, the image can be larger or it can be smaller. It depends on the scale factor. It's just they do have to be proportional. So the scale factor is greater than 1, the image is an enlargement. And if the scale factor is less than 1, the image is in a reduction. Now, our scale factor is always, when we do it, will be greater than 0. So it's really between 0 and 1 is a reduction. And then greater than 1 is an enlargement. So to be more exact. Okay, so this kind of walks you through what we're doing. So what I would do is pause and read through all of these steps. I'm going to show you these steps on the second one for it, but you can like walk through it and try it. And we're going to use like this table to do it as well. So I'm going to just do it on the next example. But what I would do is I would pause and read this page in the packet and see if you can follow it. And then afterwards, watch the rest of the video on how I do the second example. Okay, so we're going to kind of flip back and forth between the two pages. So what we're going to first do, and again, I'm going to do it this example, is we're going to take our points, our original, our pre-image, and we're going to plot the center if it's not plotted. And then we are going to figure out how we would translate our center point to each point on the triangle, okay, or each point on our image. So we're going to see how far our center is from each of the points on our figure. And that's where we're going to start. Okay, so on here, and we're going to fill out this table. This is my center, and I have this A, B, C, D, E, F, G. Okay, and I'm going to figure out how far each point is. So you can also look at the points, but we're going to always start from the center, which is the point of the dilation. And we're going to say, okay, how far do I get to my first point, A? So if I look, I go 3 to the right and up 2 to get to A. So I'm going to write that. I'm going to write R for right 3, and then up 2. And you can also like do it here. You can say 3 plus what gives me 6. So that's 3, and 2 plus what gives me 4. You can work on it that way. Okay, but so for this one to B, I'm going to say, okay, how far do I get from H to B? So I go 3 to the right. Okay, and then up 5. And you always start at this point. So B is 3 to the right, up 5. Okay, C, I'm going to count how far is it to the right. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to stop because that's how I would get to C. And then up 1, 2, 3, 4, 5. So C is right 9 and up 5. Okay, like I said, you can also find it by taking your point on your figure, on your pre-image, and subtracting the point of dilation. So here I could do like 12 minus 3, so that would be 9. And 4 minus 2, which is 2. And we're always starting at this point, so I'd have to go right 9 to get from 3 to 12, and sorry, up 2 to get from 2 to 4. So if you want to do it that way, you can, or again, you can just count each one. So we need to do. Okay, so we left off at E. This is A again. Okay, so E, if we count, it's 1, 2, 3, 4, 5, 6, 7, and then up 2. So it's right 7, up 2. Okay, for F, we count 1, 2, 3, 4, 5, 6. So it's right 6. 1, 2, 3, 4, and then up 4. So that's what I'm going to write in my table. Right 6, up 4. Okay, and then G is my last one. It's 1, 2, 3, 4, 5. So right 5, and then up 1, 2. Okay, and then this is just A again, so it's the same as that first one, right 3, up 2. It's just because it connects back to it. You don't really need that last row, would be fine without it. Okay, so then we take the scale factor. So it says we're going to do this figure. We're going to use a scale factor for an H as the center of the dilation. So what I'm going to do is that these distances I got, how far each point is from the center, I'm going to enlarge it by a factor of 4. So I'm going to multiply all of these numbers by 4 and all of these numbers by 4 to figure out how much I count from the center. So I'm going to do 3 times 4, and it's the same direction. So I'm going right 12. And then again, right 12, because I'm doing 4 times 3. So I'm multiplying all of these by whatever the scale factor is. Okay, so this one would be, if I just write it 9 times 4, so that's 36. This one I would do right, and then 9 times 4, which is 36. Okay, I'm just writing it so that you know how I got 12. So let me come back. This is 3 times 4. Okay, this is right, and then it's 7 times 4, which is 28. Right 6 times 4, which is 24. Right 5 times 4, which is 20. And the right 3 times 4 again, which is 12. Okay, so I multiply all of my movements by that scale factor. And then I'm going to do the same for the movement up or down. So all of these are going to be up again because each one we did up. So this one I'm going to do 2 times 4, which is 8. 5 times 4, which is 20. Again, 5 times 4, which is 20. 2 times 4, which is 8. 2 times 4, which is 8. 4 times 4, which is 16. 2 times 4 is 8. And 2 times 4 again, which is 8. Okay, so this is how I'm going to move. So the last part, and again, you can either count it or add it. I find it much easier to add. You just have to remember what to add it to. So we are going to, these are the new distances we are moving from the center. So I'm like starting at H, and now I'm moving right 12. So it's at 3. 3 plus 12 is 15. And then I am going up 8. So 2 plus 8 is 10. And this would be my new A prime. Okay, and it's the distance from the center is increased by a factor of 4. And so like I said, it's easier generally to just do that here. And so what you do is to find your A prime, you take, it's always the center, okay, or the point of dilation. And I'm going to add how much I'm moving. So the 12, right? And then I'm taking 2 and I'm adding the 8. And so then I get 15, 10 as my new A prime. Okay, so for B prime, I would be doing, again, the center. I'm always doing the center, 3 plus 12, because I'm moving 12 right after the dilation, and 2 plus 20, because I'm moving 20 up. And so that's 15, 22. Okay, C prime. is we're going to take 3 and add 36, and we're going to take 2 and add 20. And so we get 3922. So again, always going back to the center. So I'm going to do 3 plus 36 because I'm moving right 36, and then 2 plus 8 because I'm moving up 8. And that's 3910. Okay, E is again starting at 3, 2. The X value of 3, I'm moving right 28, so I'm adding 28. And the Y value of 2, I'm moving up 8, so I'm adding 8. And we get 31 and 10. And I'm doing that for each point. So I'm again adding the same center every time to how much we're moving right for the X coordinate and up or down for the Y coordinate. Okay, and this again is the same as the first one, so I'm just going to put 1510. Okay, then you need to graph it. So the one on the homework, you do need to graph. So I'm going to go back and graph all of these points. And it should look like that it's 4 times as big. So I'm going to do 15, 22 for B prime. C prime was 39, 22. D prime was 39, 10. E prime was 31, 10. F prime was 27, 18. And then G prime was 23, 10. Okay, and so what should happen is like all of these lengths should be 4 times as big as this. So this length is 3. And then, sorry, the distance should be 4 times as long. So like the distance from A to H is 3. And so from H to A prime should be 9, which it is. And also the side should be. So this is 3, this is 12. And then if you wanted to figure out if your scale factor is right, you would say, okay, 3 times what gives me 12, which is 4, and that's right. And so all of these sides, like A to G is 2, A prime to G prime is going to be 8, which it is, because it should be 4 times as long. So that's how you do the dilation. And just kind of notes that they have in the packet is, yes, it's possible to have a dilation movement to the left or down. The movements depend on the center point of the dilation. And it is possible to have a scale factor between 0 and 1, such as 1/2. Such a scale factor will shrink the shape. Of course, a scale factor of 1 will produce a congruent shape. Okay, so that's dilations. There is a homework problem very similar to this one that you will need to do. If you have any questions, just let me know.